What we have today is a DV4 system that was sent into us. Unlike the previous systems that we've been working with and working on, this system is a AMD with a ATI chipset. Contrary to popular belief, the Toshibas and the Acers that have the ATI chipsets, just like this DV system, do have chipset failures. But unlike the previous HPs, this system displays a different error code system. So we have this one start up, and it shows the lights come on just like that, and then the system will actually go to high fans, and then will display by the caps lock key, which is here, a blinking light. Now that blinking light that comes on tells us that there is a actual motherboard issue. Whether that motherboard issue is linked to the RAM or that motherboard issue is linked to the actual chipset failure, we won't know until we actually start to diagnose it. But we'll get to working on that here in a minute. So now we've taken this DV4 apart, and we can notice that unlike majority of the systems that we work with, this thermal compound is actually not solid. So this processor is actually a different processor. It's actually not the X64, but it is the single core Turion. But this will be the shared video ATI chipset. So we're going to reflow this and then test this chip and make sure that the 2 gig stick of memory that came with this actually doesn't have any errors on it. So we'll get to reflowing this here in a minute, and then we'll go from there. Okay, so I get a lot of emails that ask me what temperature I reflow at and how I do it. Especially with these systems being ATIs, I'm kind of delicate with them. So you're looking at 150 degrees is what the preheater plate gets to, and that would be the ceramic portion that's underneath. Then you have 200 that comes out of the light, so 200 that comes out of here, and then the distance, if we're going to gauge it, is about, your hand could be underneath it. So that being said, we turn it on. You just basically turn it on like so, and the light turns on, and you make your adjustments, making sure that the light is focused over top of the actual chipset. Now what this is going to do is it's going to physically heat the chipset, the solder underneath it, but not aggressively heat the capacitors that are on top. As an example, you have your CPU here that has the capacitors on top. Now, what you don't want is those to fly off when you're using hot air, and that's a major problem. A lot of people say that off-gassing causes the issues, but the major issue is capacitors being removed and the power not being able to be returned to the chipset, hence your motherboard doesn't work. So we're going to let this heat up and do its thing. It goes for about 2-3 minutes, and then we'll take it off and let it cool down for about 30-45 minutes, and then we'll put it in the system and see what happens. So now after a reflow, we're sitting here about to test the system. So what we do is we'll turn this on, and when we turn it on, we see the 2 lights come on, but not the caps lock light. Nothing's being displayed on the screen. So this is a fairly common issue that is with the ATI DVI systems or DV systems. What you have happen is now after a reflow you've either got a processor issue or you've got a memory issue. So this is something other that you'll have to check. The light not turning on over here signifies that there's not a general motherboard problem, but now there's a component level problem, because the hesitation should only be for 5 to 10 seconds, and then the system should initialize within the backlight. So we had no initialization, nothing turn on. So what we're going to do is we're going to take the processor off and then we'll test it again. So now we're going to turn our system on and see if changing the processor is actually what's going to fix it. We have the lights on and we're going to check to see that the screen turns on. Got a backlight and an initialization. Looks as if we have an actual screen. F2 takes us to where we need to be. We have boot up and everything. System has turned off and is turning back on, and that's pretty common with a system that we have in diagnostics. Don't have heat sinks or anything like that on it, but it's pretty common that it works. Now here's something that we actually use when we do our testing. It's called Super Cold 134. Now what this does is it'll actually seize the chipsets and actually seizes the components, so you can test and see which ones are bad. Now we did a CQ60 video before, and that CQ60 video actually displayed an overheating component where we took a thermometer and tested it. Now with the Super Cold, all you have to do is hit that and it seizes the component, and if it seizes that component, puts it back into alignment with its normal operating frequency and temperature, then what happens is that allows you to actually test it and see which parts are bad and which parts aren't. So we actually did that with this board and hit the processor, and the processor actually seized back into working. So by that happening, now we know that we need to change the processor. That actual stuff allowed us to do it. So that'll be that. We need to put it back together and make sure everything works. Okay, so what we have here is our finished laptop after we have sprayed it down and changed the processor after we realized that that was what was wrong, and now we're going to check it, make sure that all our work is completed, and pretty much have a running system. So we'll turn the system on, see if we get the prompts that we need. Backlight initialized, BIOS screen cut on. So what we're seeing here is a working system. Pretty common after a reflow is that your system will show Windows needs to recover from a failure. It's actually booting up into 7 or Vista, whichever one, but it appears that the system is actually working. So we'll just make sure that it goes into Windows, and then after that, appears the system's done. We have a cursor there, scrolling cursor. Now it appears that everything's good to go. That's an actual started system. It looks like it works.